Hello everyone, welcome back to Advent of Code. Day 10 of 2023. As usual, not always, but I typically do not look ahead at the problem statement before starting the video, so you guys can just sort of hear, me thinking through all of how to solve the problem. And that's the case today. I haven't looked ahead. I did happen to catch some chit-chat on the functional programming Discord server that it sounds like today is going to be a hard one. Given how much of a mess I made of yesterday's easy problem, you might need to buckle up here for a long one, or I might need to take a break and do it in 2 sessions, or just quit forever and never write another program in my life. We'll see. Let's get started on day 10. Pipe maze. You use the hang glider to ride the hot air from Desert Island all the way up to the floating metal island. This island is surprisingly cold, and there definitely aren't any thermals to glide on, so you leave your hang glider behind. You wander around for a while, but you don't find any people or animals. However, you do occasionally find signposts labeled Hot Springs, pointing in a seemingly consistent direction. Maybe you can find someone at the hot springs and ask them where the desert machine parts are made. The landscape here is alien. Even the flowers and trees are made of metal. As you stop to admire some metal grass, you notice something metallic scurry away in your peripheral vision and jump into a big pipe. It didn't look like any animal you've ever seen. If you want a better look, you'll need to get ahead of it. Scanning the area, you discover that the entire field you're standing on is densely packed with pipes. It was hard to tell at first because they're the same metallic silver color as the ground. You make a quick sketch of all the surface pipes you can see. This is your input. Okay. So we have vertical and horizontal pipes. We have the 4 90-degree bends. It's funny. I looked at this character and I thought this was some, weird Unicode, upward to rightward bend. And I was like, oh no, J, 7, and F. This is just the letter L. Okay, got it. Dot is ground. There's no pipe here. S is the starting position of the animal. There is a pipe on this tile, but your sketch doesn't show what shape the pipe has. Interesting. Based on the acoustics of the animal's scurrying, you're confident the pipe that contains the animal is one large continuous loop. Okay, sure. Here's a loop. If the animal had entered this loop in the northwest corner, the sketch would look like this. In the above diagram, the S tile is still a 90-degree F-bend. You can tell because of how the adjacent pipes connect to it. Unfortunately, there are also many pipes that aren't connected to the loop. This sketch shows the same loop as above. But then there's a bunch of other random pipes everywhere. Now, this is interesting. There's an F here that points into part of the pipe, part of the loop, but this doesn't point back up into it. So I guess it's possible that our input might have a pipe going down into the S that isn't actually connected to it. We can't just say, oh, okay, we'll derive what S is by looking at what's next to it. This feeds into it. Okay, it must point to the right. This feeds into it, must point down. Great, it's an F. In the above diagram, you can still figure out which pipes form the main loop. They're the ones connected to S, pipes those pipes connect to, pipes those pipes connect to, and so on. Okay, so maybe they are promising that there won't be confusing things pointing into the S. Because they're saying, basically, I think, that you can start from S and trace outward pipes connected to it in every direction. Okay. Including S, which will have exactly 2 pipes connected to it, and which is assumed to connect back to those 2 pipes. Okay, fine. So we can basically tell that this S is an F just from looking at the things adjacent to it. Fine. Here's a sketch that contains a slightly more complicated main loop. So this S is connected to a J, so okay, it goes like this. There's no distractions there. Now here's the same example sketch with the extra non-main loop pipe tiles also shown. Yeah, so from this S, we can get to the J and say, yeah, that's connected. Okay. And this doesn't seem so bad so far. If you want to get out ahead of this animal, you should find the tile in the loop that is farthest from the starting position. Because it's in the pipe, it doesn't make sense to measure this by direct distance. Instead, you need to find the tile that would take the longest number of steps along the loop to reach from the starting point, regardless of which way around the loop the animal went. I say it doesn't seem so bad. I mean, like, it's still going to be work. But I don't think we need some novel algorithm to figure this out. You just flood fill starting with S. And, like, you mark those as being the actual pipe contents. And then to find the thing that's farthest away, you basically send 2 probes simultaneously out of it in each direction, right? So you send something from here east and something from here south. Then we step them both. This one keeps going north because that's where the J points at. This one goes south. And we keep going until they meet, and that'll be as far away from the S as you can get. Yeah. Or, okay, count the distance each tile in the loop is from the starting point. I guess that's another way to think about it. Is to build like a, what do they call these? Like a pathfinding, it's not really a pathfinding, right? But a contour map, kind of? Okay. Find the single giant loop starting at S. How many steps does it take to get from the start to the point furthest from the starting position? And in fact, you don't even have to do the flood fill, right? You don't even have to figure out what's part of the main pipe and like isolate it, at least for part 1. You can just start at S, figure out which things connect to it, and therefore infer what shape this S must have, and then send 2 probes out of it in the 2 directions that it connects to, and they'll only meet tiles that are part of the big loop, right? And so they'll just bounce around until they hit each other, and then you'll have your answer, right? Is there some reason it would be better to compute the distance everything along the loop is? Maybe for part 2, but for part 1 it seems like a bunch of work. Well, I don't know. I guess you can kind of compute the distance as you go, right? While we're sending these 2 probes along, we can be updating another map somewhere that's like an index from plane coordinates to distance from start, if we wanted, right? That makes sense to me. Okay. Well, we have some, data type modeling and some algorithm work to do, but it doesn't seem like we require any particularly complicated algorithm to solve this today. Let me get my input. $140 by 140. Okay, so it's large. But that really doesn't matter, right? Where's our S? It's not... Yeah, it's not on the edge of the map, so we don't have to worry about... index out of bounds kind of stuff. And indeed, there are exactly two pipes pointing at it, right? Oops. This points at it. And this points at it. No, I don't like transient mark mode. Get out of here. Or maybe I don't understand how to use the mark. Okay. Whatever. And then to the right of it, there's an L, which obviously doesn't connect. And above it, there's a horizontal section, which doesn't connect. Here. So, fine. So how do you describe these pipes and their connectivities? Do we want to use cardinal directions, north, south, east, and west? And say that a horizontal pipe is a pipe connecting east and west? I think that sort of makes sense, right? And then figuring out, like, for the curvy pipes, it's a little more interesting because a function we're likely to want is one that says, given a direction I'm currently traveling in and the shape of the pipe that is currently around me, what should my new direction be? How should I travel out of this pipe? And so for east-west, it's very easy. You say, oh, we're connecting east and west. So if you're coming in east, well, you should continue going east, I guess. And if you're coming in west, you should continue going west. And if you're doing anything else, like you should go to hell and die, because that's impossible. Likewise for north-south, you just continue. For the bendy pipes, it's different. Let's suppose we have an L pipe. Let me find one on the screen here L. There. Now you know what an L looks like. It looks like that. If you're coming into this going south, you should head east. And if you're coming into this heading west, you should go north. So, like, we would say that this pipe connects north and east, but you never go from east, traveling eastwards to traveling northwards or vice versa. You go from, like, traveling the opposite of one of those directions to traveling the other, or from traveling one of those directions, traveling the opposite of the other, sort of, right? Like, if the pipe connects north and east, then you're either coming into it the opposite of north and should go east, or you're coming into it the opposite of east and you should go north. Right? That's kind of attractive. So we describe a pipe by which two directions it connects, and we reflect our ray off of a pipe. I usually think of these as like mirrors bouncing light rays rather than pipes for this kind of problem. So hence reflecting a ray. You can imagine a ray traveling along the pipe and being redirected at each corner. And to determine which way to reflect a ray, we find which of the two pipe's endpoints is the opposite of the current direction you're traveling. and then give you the other endpoint, right? I think that makes sense for the corner ones. Like if it's a northeast pipe, like an L, and you're traveling south, you look up, okay, which pipe's endpoint is the opposite of south? That's north. Okay, give me the other one, please, east. And if you're traveling west, you say, what's the opposite of west? It's east. Now give me the direction that isn't east. And it would send you north. Yeah, that makes sense. Does that same idea hold for the straight lines? They connect east and west. So if you're traveling west through a pipe, you say, through a horizontal pipe, let's say, you would say, what is the opposite of west? It's east. Now give me the side of the pipe that isn't east, and that'll be west. So that makes sense. You keep going straight. So I think that's kind of how to decide how pipes reflect your motion. Okay, cool. So let's start defining some stuff. We're going to need a few things, and several of these are things that, like, if you had an Advent of Code library that you used every year and every day, you could just, like, borrow this from your library, but I don't mean, like, there exist libraries for, like, you know, the Advent of Code API or whatever, but I mean, like, your own personal library for tools you like to work with that you designed over the years that repeat in Advent of Code. If you had one of those, it would certainly have stuff like coordinates and directions in it, but I don't know. I just solve each problem from scratch. Why not? So, I think we need a few things here. We need directions. Whoops, data. Direction is, which one? North first, I guess, would be the least weird. Show, eq, and ord. And I guess enum is fine. I don't imagine we'll need it, but maybe. Do I need, I wonder, to even have, like, it seems obvious, maybe I'm wrong, but this is my first inclination, is to say, what is a pipe? A pipe is a pipe from, you know, direction to direction. Right, we derive, show, and I don't know, maybe we need eq and ord? But I don't think so. Let's just derive show. So this is something that seems sort of obvious. A pipe connects two ends. But it has a few problems that I see. And I haven't thought through yet, like, whether they're important problems or what the right fix to them is. One obvious problem is that it allows you to construct impossible pipes. You can say, you know, magic is a pipe from north to north, like it's a U-turn. Those don't exist. We shouldn't be able to define such a pipe. So that's a problem. Another problem is that there are multiple valid definitions of the same pipe, right? We could say, you know, A is pipe from north to east, and B is pipe from east to north. And those are the same pipe, but expressed differently. And it would be nice if there were only one uniform representation for the various types of pipes, right? I don't think I don't think either of those is going to, like, really make it difficult to solve today's problem. But it's just their code smells, right? They're warning signs that you're not modeling the problem correctly. Because, you know, one of the Haskell mantras is make illegal states unrepresentable. this isn't really an illegal state, it's just kind of weird. The other thing about having a pipe that goes from north to north, that is an illegal state, and like something's wrong there. So what could we do instead? One thing we could do is just like, instead of this definition, we could use, say, data pipe is horiz or vert or we could put FJL and well, not 7. I mean, we could FJL or 7, right? Like, we could do that. That would be all of the pipes. We'd then need to, like, understand, every time we touch a pipe, we would have to understand all 6 of these constructors, instead of just having to understand a pipe is a pair of directions. But maybe that's fine. Right? Like, let's imagine, let's not imagine, let's try writing, like, transit is a function that takes a what do I want, the pipe argument first or the direction first? How would I expect to apply this function? I don't know. Let's say it takes a pipe and a direction and returns a new direction. When in doubt, let it partially apply to an endofunctor, huh? Haha. And some of this is kind of easy, right? Transit of horiz is id. Transit of vert is id. Like, we can just say, keep going the same way you're going. If you got here, you must be going straight. Right? And then this is actually interesting. If you look at the 2 pipes, or the four shapes that bent pipes have, there's sort of like F and J are the same. Sort of? I'm not sure. Like, they're the same piece. If you just rotate it, you would get, if you turn an F 180 degrees, you get a J. If you turn an L 180 degrees, you get a 7. And so F is kind of like, I want to think of this as being clockwise. But it's only clockwise if you're going north. Right? If you're going left, if you're going west, it's counterclockwise. So maybe okay, let's try this. Transit dir is case dir of, and then I can both make this a little shorter and squeeze in a case or a where clause that attaches to all of the directions. And like otherwise it's connect of dir, sort of? Does that make sense? where connect of, I'm going to case match again here like a damn idiot. So this isn't quite right. I kind of want to say angles of dir. Or endpoints? Maybe? So we can say endpoints of f is southeast, right? Endpoints j is north and west. Endpoints of L is north, east. Endpoints of 7, oops, is south and west. And so here we can do this connect thing that I was talking about, of just looking at the direction and finding which of these two is the opposite of what you're doing, kind of, right? Connect of A and B and dir is equal to reverse of A equals B, otherwise equals A? Is that right? Reverse, so if you're coming into an F from the north, if you're headed north into an F, then you should go east. And that makes sense because your dir is north, reverse of A is north. Great. If you're heading into an F not heading north, then you must be heading west because that's the only other way into the F, and you should go south. So yeah, I think that makes sense. So I don't know. I kind of like this idea. Oh. Wait, where's my pipe? Like the whole pipe argument disappeared. What am I matching on? I guess I want the endpoints of the pipe, I guess. So it's connect composed with endpoints. Endpoints is a function taking a pipe. Oh, already this is messed up. Okay, I want it to go this way, please. The pipe, yes. So we're taking a direction and a pipe. We're returning a new direction. Well, id doesn't make sense. Oh, wait, no, we're... What is wrong with me? Okay, hang on, come back. This all looked correct. Except for this part down here. But this just should have been called pipe all along. Okay. The function connect is applied to two value arguments. Well, sure. Oh, hang on. Connect composed with. No. It is supposed to be connect applied to, so connect takes the dir argument finally, right? And reverse is this crazy function we haven't written yet, right? In fact, I'll just call it invert to avoid conflicting with the one in Prelude. I guess invert. God. I don't want to have to write invert of north is south, invert of east is west, and so on. 4 clauses. Invert is 2 enum mod for +2 from enum. Okay. Patterns of pipe not matched? An equation for endpoints. Oh, that's true. I mean, I have this like whole special case for horizontal and vertical, but it kind of sucks, right? Like, why not just write endpoints for horiz and vert, right? Why not just always say it's connect to the endpoint of pipes, endpoints of pipe. And really, like, you can just do that, right? This isn't correct because I'm not handling horizontal or verticals anymore, but I'm just eta reduced to make the parameter implicit there. And if we just write endpoints, P is case P of, so I can make this shorter, F J and now we can just put in the horiz is connecting north and south, east and west, and vert is connecting north and south, right? This way, the compiler can prove that we're handling all the cases, except for the fact that we're smuggling stuff into an enum, which looks very spooky. Could easily be wrong, but I think it's right. So what do we get then? Let's test this out. If we transit, takes the pipe first, right? Yeah. Transit from an F into an F, and we're moving north. It should say east, right? Yeah, easy. We're going west, it says, oh, you should go south. And if we say, oh, I'm coming at this, I'm heading south and I've arrived at an F, it should say go to hell, right? No, it just like says something random, but that's fine. Right. So that's kind of cool. We have a way to tell. And I mean, really, endpoints should be a top-level function, right? Because we're going to need to look at the pipes around the S and tell which ones of them are connecting to the S. And the obvious way to do that is to ask what are the endpoints of those pipes. What is a good way to trick Haskell into letting me cut and paste this? Or to trick Emacs into letting me cut and paste this block and not have shitty indentation everywhere? I think what I want is to say where x is 1. Now I have a block that I can de-indent all in one and do that. Now get rid of the x is 1 and it lines up better. Okay. Endpoints takes a pipe and returns a pair of directions indicating what the pipe connects to. That looks nice. I like it. To transit a pipe gives you... Oh, it even comes out like nice English. Oh, to transit through a pipe is to connect its endpoints. Just sort of by coincidence. By the way, this like, I don't know, I mentioned briefly Ada reduction and like... So what I used to have was pipe is connect of endpoints pipe. And we're already sort of being implicit here because, like, what about the directions? Connect endpoints of pipe to dir, right? This is the same function. But it's nice to think about things in terms of function composition rather than in terms of, like, applying functions to arguments. You know, those both are good perspectives some of the time, but I think thinking of programs as compositions is philosophically nice. And so when you have, like, you know, transit of pipe is a function we're defining, and it takes an argument, dir. Really, of course, transit is also a function we're defining. It takes two arguments, but transit of pipe is also a function with one argument. Its argument is dir. And what does it do? It finds this other function and calls that function with dir. So, like, really, we don't need dir at all. We can say transit of pipe is this other function. And that's fine. And that's the way that it sort of is, I think, fairly natural to think once you've programmed in Haskell a bit. I still have some trouble with this next step of, like, wait a minute. Like, this one I did without ever writing out the dir because I knew we would just be, like, calling some function on dir. But then I had to look at this and be like, wait a minute. What's happening with pipe? Transit is this function. It takes one argument, pipe. What does it do? It, like, calls endpoints on this other function and then calls connect on the result. Sorry, it calls endpoints on pipe. So, like, that's the same as just composing connect and endpoints, right? I don't know. It looks nice this way. But just explaining sort of how I got there, I guess. Now, what we don't have yet is a way to go from two directions to the canonical pipe type, right? If I say, oh, you know what, there's someone who's definitely connecting to me from the north and the east, how do I find out that that's an L? We have a one-way function that takes a pipe and gives you the endpoints. We don't have one that goes the other way. And we are going to need that once for when we look at the S and try to see, hey, what are you connected to, man? That's one downside of our choice to represent pipes with these 6 canonical constructors rather than as just being a connection of two endpoints, right? If I'd said, like, this is what an F pipe is, it's just the pair south and east, then I could construct a pair southeast or indeed even a pair east-south, and it would be equivalent. And I could just jam that in over top of the S once I figure out what it's connected to. I think maybe I'll let that sit for a minute and work on something else instead. This, well, I mean, I guess this should deriving show and enum is probably enough. Actually, do we want, we might want econord. Why would I want that? No, I don't want that. I don't even think I need enum really, but maybe there'll be some reason for it. Invert should also be a global function, shouldn't it? Function from direction to direction. So let's take a minute, I guess, to define some coordinates, right? Coordinate of A, do I really, like, why don't I just make it be a pair of ints? I guess I'll do that for now. Sometimes, I don't know. A coordinate type is something you define a zillion times in Advent of Code, and some days I feel like I should parameterize it, some days I feel like I should just make it ints. And I can't remember which times it has worked out better, so it holds 2 ints. Although, what if I made it a new type wrapper around a pair of ints? Then we could derive some type class stuff for it, maybe? I don't know. Well, I wonder, actually, if it might be nice for these to not just be a tuple, but to be a slightly different type so that they can implement foldable, and I can just say, give me a list of the 2 elements there, and then ask, like, is south a member of that list or something. I don't know. We'll just, for now, let's just leave it alone. Show ecord we will need, because these will need to be keys in a map, I imagine. And we need, like, a function from direction to delta, right? So, like, let's say, do we call these deltas or we call them units? The basis vector or something? I don't really know what a basis vector is, but like a unit vector in a coordinate space, right? I guess I want to call it unit as a function from direction to coord, where we know the coordinate will have a 0 and a 1 in it. It's kind of gross, but let's actually call these x and y. so you can't get confused. Dehow? Oh yeah, that should say show. Unit of north is will arbitrarily. So this is I always like, I don't know, coordinate systems, right? You can pretty arbitrarily define a coordinate system, and there's kind of two popular ones for XY planes. One is the one used in, you know, geometry / calculus, where like the origin, well, the northeast quadrant of this coordinate plane has positive x and positive y, right? The other popular one is the one that like computers often use based on like, you know, oldie-timey monitors, where the top left of the screen is the origin and y is usually listed first because it's like row major basically. So as y goes up, you go down in the coordinate, like you go lower conceptually on the screen. And those are both perfectly valid coordinate systems that you can solve all of these advent of code systems, whichever one you choose. You just have to remember what you're doing and be consistent with it. And I think, like, because we're reading in the input as a list of rows, and the first one is, like, the highest one, I think we should choose, you know, y to be the first coordinate. And for 0, 0 to be the top left. You know, that's just how we're going to do it. So north is our unit of, there is case dir of north. We will have coordinate -1, 0, right? Because when you go up, y is decreasing. Yes. South is coord 1, 0. East is coord 0, 1. West is coord 0, -1. Wuset? How about west? And we need like a monoid instance for our coordinates, basically, using sum. It's a little like, I don't know. You could say, and I have in previous years said, we're not storing ints here, we're storing sum of int. SUM sum, where we plan to add these ints together. I don't know. People made fun of me for contorting myself into that abstraction. So I think it's probably best to just say instance semigroup coord where coord x1 y1 added to coord of x2 y2 is coord of x1 plus x2. Oh, these aren't x's, these are y's. Y x y x. So this is the kind of thing that the compiler absolutely could derive for you in a variety of ways, but I don't know. I would have to contort my definition of coordinate to use some event, basically. And then maybe use some generic deriving via thing that I don't quite know about. I don't know. Instance monoid coord where empty is coord 0, 0. So now we have a way to add together coordinates. And even if we really wanted to, a way to add together a list of coordinates. Which will be useful for like going when I say I want to go north by 1, I'll take my current coordinate and I'll append it to the unit of north, and then that'll be my new coordinate. I still haven't gotten to the part of detecting what shape of pipe the S actually represents. For some reason, I feel like putting that off for longer still. It just sounds like kind of a nuisance, a bore. So let's instead write a parser, shall we? I mean, do I even need a regex applicative here? I really don't, right? It's such a simple... it's just like a map. We map a function over each line. And that function is like look up a pipe by name, right? Let's actually, pipe by name takes a char and returns well. We kind of need like some way to represent S, the start, right? I'm a little tempted to just do this S shit by hand. Right? To go in here and say, you know what? What are this thing's coordinates? And I'll just replace it with a 7 by hand and tell my program what coordinates it should start at. That seems highly unethical. I joke, of course. You can do whatever you want in Advent of Code, whatever you think is going to make the exercise useful to you in whatever way you want it to be useful. And really, exploring the neighborhood around the S isn't that fucking hard, right? It's just a little annoying. The problem is, like, I have to represent the state before I've parsed it. And I guess that means I should parse into either a start label or a pipe. Then, once I've figured out what pipe is underneath the start label, I can have like an array or a map, I guess a map, of pipes, ignoring the start label thing, and then separately have a starting coordinate. So I guess it makes sense to parse into I guess I'm going to say maybe. And if there's nothing there, then it'll be implicitly the S, basically. Maybe we call it pipe, right? Pipe by name, C is case C of, or is, well, hang on. can we do better than this? Can we zip the pipes with the string representation of them, right? I mean, we certainly could. But handling start is just such a nuisance, right? Well, I don't know. I guess maybe we could say pipe by name is lookup in a list. And the list is S, nothing. Now, because we're actually returning a maybe here, and lookup itself returns a maybe, what lookup is going to give us is a maybe of pipe. But that's okay. We'll call from maybe on it with like an error, couldn't get this character or whatever. And then cons this to zip Horrors vertical FJL7. Zip that to map just over I guess 2enum 0 like that. So this won't quite be right because it returns, oh, I don't fucking know. From maybe undefined. Okay, I need to import that, of course. Import data maybe from maybe. So basically it's saying the type is wrong by 1,000,000. Oh, is lookup lookup probably takes its arguments in the other order, right? Yeah, okay. Flip lookup then. Yeah, so lookup wants the key first, whereas I'm trying to call lookup and pass it the dictionary. So I flip lookup, getting back a function that wants the dictionary first, and then apply to this function this argument. So from maybe like error, no such jar, no such pipe. And then let's say where pipe names is this. All right. I mean, that doesn't look so bad, right? So now if I were to say pipe by name of f, should be a string, not a character, not a string. It's just f. You know, I say 7, it's just 7. S, oh, nothing there. There's no pipe. If I say Q, it should like break, right? Perfect. So we now have a way to turn a single character into a pipe. And I kind of want, as always, I have an input type, which right now is list of string, but it'll be something else. And I want to pass that input to part 1 and part 2. I feel like figuring out what shape the S has and what your starting coordinates are part of preparing the input. They're not part of part 1 or part 2. Hopefully. Hopefully part 1 and part 2 both have the same meaning for S. So I think I want my input to be like a data type containing two elements. One, the map of pipes, which I think I'll just use a map for. An array is more efficient, but like they're just a pain to use. I don't know, they're not that hard, but I always have to go look up the documentation for how you work with arrays. And it's not that gratifying when you do. Like, you get constant time performance instead of logarithmic performance on something that's 140 characters. Like, who cares? Didn't 140 used to be the length for a tweet, by the way? Is this like a square tweet? This is like a tweet squared? Funny. Okay. But of course, these days tweets are longer, and they're not called tweets anymore. I don't know. I'm not on Twitter. Haven't been for a decade? Not sure it's been that long. But pretty close. Maybe longer. I don't remember. Anyway. Who cares? Why am I talking about this? So in prepare, we're first going to let's say it's orient composed with map pipe by name composed with lines, where orient is a function from list of maybe pipe to input, and orient is undefined. I just want to check if you agree with me about the implementation of prepare. Yes. It says if you really could write an orient function of this type, then prepare would type check. Great. So our data input is an input of origin, I guess, which is a coord, and pipes, which is a map from coord to pipe. And we need maps now, of course. Data map. Can't imagine why I would need a lazy map today, so we'll use strict. Qualified as m. Okay. So I think I want to do like a stateful for loop. over the list of pipe to produce the map. And the origin, right? So that, I don't know, that makes sense. The annoying thing is there isn't really a very nice type-safe way to do... I mean, I can't think of a good type-safe way to describe what I want to do to the map. Like, when I first parse the list, I'm going to get out a map of maybe pipe, because there's an S where the maybe should be, right? Well, maybe it's fine. Then I can just fmap over... Well... Do I want to fmap exactly? I want to do like map with keys or something. Does that exist somewhere? It must. I don't have my data map documentation over. Open. Data map strict. Isn't... I want this module. Yeah, I don't know why those showing me I guess those... Anyway, it doesn't matter. So, if you want to traverse, right? That's what I want to do. Map is fine. I think I want map with key. Where... we take all of the just pipes and replace... We're going to have a map of maybe pipe and no known origin. And then we're going to want to turn that into a map of pipe where there are no longer nothings allowed. And we'll also want to know the origin. So... Well... Actually... Do I want traverse with key? Because I want to be able to emit some state from this, I think. Which is like saying, here's where the origin was. So what are the type of traverse with key? Assuming T is applicative, which let's just say for now we're using writer. A function from key and A to T of B. Map KA gives you a T of map of KB. Yeah, I mean, that makes sense. So that's how to do... Or should I just use map accum with key? Maybe that's what I want. Because I think traverse and map accum are kind of the same. But if I just want one value out, I can thread a nothing through until I find the origin, and then start threading a coordinate pair through. That makes sense. So I think I want map accum with key. We'll start A as nothing. And then when we find the origin, we'll make it be just the coordinates that we're currently at. And if we find anything other than the origin, we'll just ignore A and pass it along unmodified, right? And we're going to still take our A and K, the location we're at, and the current pipe, and produce a B in the current maybe pipe. Which I guess that's A? No, it's B. And we'll produce the new knowledge about the origin and the just pipe that is there. And for everything except the origin, it'll be very, very simple. I think that makes sense. I think I want to use mapacume with key after first turning the list of lists into a map from coordinates to maybe thingies. So orient of grid is oh, this is annoying. How did I do this last time we had a grid to parse into a map of coordinates? You want to well, actually, I think you just want to zip. Okay. It's m dot from list of do. No, I think already I'm wrong. No, it's fine. Y is from, or no. Y and row comes from zip 0 grid. Then X P, I guess, is from zip 0 with the row. Does that look right? I think it looks okay. Then we will return pure of my coordinate takes coord y x. Still has to be a tuple though, because we're giving this to m.from list, and then we're putting a p there, right? Now, this isn't really the result of orient grid, because this is just returning. Okay, let's let initial grid equal this, I guess. In apply some function to grid. Will you help me with? Yeah. Oh, not the grid, the initial grid, of course. So it's saying, great, you have a map from coordinate to maybe pipe, but you still have to turn that into an input. Yes, that's what I hoped it would say. Good. So now we were saying we want to map a QML something over the initial grid, right? That was the idea. Map a cum with key. We don't want to write in yet. You know, maybe our input can just be a tuple, because that's what we're going to be getting back. Oh, I guess it's just coord and map from coord pipe. Like, Maybe we'll just use this type alias, because that's what we're getting back from mapacuml anyway. In, and then I really can say in, mapacum, oh, it's not mapacum, with key? With key. Mapacuml is a thing for lists. With key of... Oh, I don't know. I just want some vague word that doesn't mean anything. Call it process, call it go. Who knows, man? Go. Gross. Nothing. Remember, our initial knowledge of our coordinate system is nothing. Oh, you know what? We're actually going to need a little bit more than this. We're going to need to say origin pipes mapcum key go nothing initial grid, right? Well, I don't know. I guess what I'm supposed to do is not actually that. In this, but we'll say case this of nothing, anything to like error, couldn't find origin. Just O M to be like O M. Right? Oh, m.mapacum with key, please. And of course we haven't written go yet, but that's okay. We're getting there. Go is not actually all that complicated, I think. I might want to slap a type signature on it, though, just in case. Oops, that's not how you do that. And then we can go back here and say go equals. Well, actually, I guess I want to do this first. Go is undefined. So if we did that, this would all compile. We just have to write go. Fine. Go of maybe coordinate. So this is our origin. The coordinate that we're currently at is C. And if there's no pipe here, that means if there's nothing here, that's how we've indicated this is the start position. This is where the start was. So we have to then return just C and infer pipe type of C, I think. We haven't written infer pipe type, but we'll get there. We'll get there. Actually, that's a little annoying. We don't have the grid of pipes in scope for go here. So go has to be defined in this let block. Oh, that's too far. There. Because now initial grid is in scope, and we can look stuff up there. And it should be all justs, which is a little annoying, but... Well, Go is a pretty bad name now. Whatever, we can rename it later. Go of O, C, just P. There is a pipe there. We just return the origin, what already the origin was known to be, and P. That's easy. The problem is we have to write infer pipe type, which we haven't done yet. Infer pipe type coord xy is. Oh, I mean, it sucks, right? Because we can say, like, well, I guess what we want to do is get a list of all the directions that you could go from S, i.e. north, south, east, or west, and then filter that list to only those directions which have a pipe pointing at S. Then check that the list is exactly length 2, and find the pipe type that contains those two items, right? We still don't really have a function that takes two directions and gives you a pipe type, but we could have such a function. Right? I mean, it's a little yucky, but we could just try all of the known pipe shapes and see which one gives you either the list you were looking for or the reverse of the pair you were looking for. Like, that's fine, right? Okay. So I guess we want, like, case filter. I don't need X and Y, we'll just call it C. Case filter points at C of I and J, I guess, are traditional names for unit vectors. Well, they're not unit vectors, they're directions, but... Oh, I have to say... from enum 0 direction of. So yeah, starting with give me the whole, all the directions and filter them. If there's ij, then make pipe of ij, I guess. Anything else, error, origin connected to by show x's, I guess. Now we have to write points at, of course, and make pipe, but we're getting there. Let's take a break from this function and go write make pipe, which is closely related to endpoints, so we'll do that. Make pipe of, I made it take a tuple, right? Yes. Make pipe is a function from direction to a pipe. Make pipe of P. I don't think I need to destructure it at all. I guess in principle, maybe it should return maybe pipe because it could fail. That's one of the things we avoided by never having to deal with a direction pair before, right? This is the first time we're dealing with a direction pair that could be wrong, could be north. We know it won't be because of how we're planning to call it, but it could be. We'll just call head. That's perfectly safe. You know, at some point I should just write a list of all the directions, right? Directions is north, right? Like, directions is a list of direction. And then all the places I had this, like, from enum thing, which I guess was just one? Okay, fine. So make pipe then, I got lost, where is it? Here it is. Endpoints. No, not endpoints. It's Q, where Q is drawn from... Oh, now I need to list all the pipes, right? Are there any other weird places I'm using? Yeah, this 2enum 0, this is horrible, right? Map just over pipe shapes, right? I knew there was somewhere I was doing something weird with. Okay. So now directions and pipe shapes look like this. It's like a little gross, but whatever. Q from pipe shapes, where P, let E be endpoints Q, and demand that E equals P or E is there like a good name for, is there a built-in function that flips tuples? I have a list, I have an AB tuple and I want a BA tuple, please. Swap, of course. Swap. Yeah, we'll just do this. Call it P prime, where P prime is swap P. It's in data tuple. Import data tuple swap, please. So we're getting somewhere now. We still like haven't written points at. and that's sort of like the hard part of all this in a way, points at points at O, we'll call it here, I guess, for origin. Points at O dir is case m dot lookup, I guess. No, I can use m dot bang because I know it'll be here, right? How do you look stuff up in here? Query, lookup. Takes the map, then the key. Okay, case. Where's my map? It's initial grid, lookup. O plus unit of dir of, and what's that going to give me? It's going to give me a maybe pipe because the initial grid has maybes in it. We know it will be non-empty though, so like nothing. Math is error, like it's error. Die. I don't know. Just P, where P is going to be a pipe type. I mean, we could say false, I guess. Shouldn't ever happen. Honestly, if it does happen, I'd like to know. Just P. There was a pipe there. We need to now know if the endpoints of this pipe include the reverse of dir. Right? How do you, like, what's a good way to ask if a tuple contains something? It's almost elem, but it's not. This is why way long ago I was talking about maybe it would be nice if my coordinate were actually a new type around a tuple where the two types were constrained to be the same. Because then foldable would give you both halves, and you could ask, like, you could just call two lists, and it would give you both of them. But, I mean, we'll just say let A be equal endpoints of P in A equal dir prime or B equal dir prime where, well, yeah, where dir prime is yeah, I guess I only need to compute the unit of dir once and the reverse of dir once. So what did I call it? Invert dir. So only warnings. Actually, I'm a little bit shocked. I know there's this one we didn't actually use. Maybe. It would be truly a miracle, wouldn't it? I'd be somewhat shocked if this whole nightmare came together into parsing the input file. Let's just give it a try, shall we? Prepare on. It's just gonna be fucking huge, isn't it? Even if I'm right. If I get something other than an error, I'll be very happy. Read file of input.txt, please. Yes, very good. Exception, no such pipe. Well, that's exciting. How dare you? C. Okay, that's still type check, so let's try that again. Oh, I forgot. The dots, there can be non-pipes there. Okay, fine. Oh. That is kind of funny, isn't it? I don't ever care about these because we're never going to traverse one of them. But sure, they exist, I guess. So perhaps maybe pipe is actually the way to go. For my representation. Like, I don't even really care about what's at, like, what any of these things are. But I do have to handle them. Oh, annoyingly, though, I was using nothing to mean, oh, this is where the start is. And now there's one more thing I need to represent, which is there's nothing here. It's really a lot more natural for nothing to be that, right? Okay. So, I guess pipe by name, we're going to need to put more than just a pipe into our grid, I guess. Let's define another new type here real quick. Data, like it's a grid inhabitant, it's an entity. Oh, it's all so vague. A landscape item, a feature? Sure. Empty, or start, or pipe of pipe? I don't think I need anything but show here, honestly, right? So this should not return a maybe pipe, it should return a feature. And we need dot to start. Now this isn't nothing. Oh, whoops. This one should say start. This one should say empty. And this shouldn't be just, it should be pipe. Oh boy. Everywhere I have a maybe needs to be fixed. Here's one. This is a list of features, I guess. And this is a list of feature as well, except I don't want to have just start there anymore. Well, that's fine. I just won't put start in. It'll be great. I'll write what should actually be there instead. I'll write what was under the start, right? Okay. For pipe type, so we're putting a m.from list of do. We're putting p in. What is p? Well, p is that's not what I want at all, is it? Oh no, it's already taking a list. I already called pipe by name. Okay. I mean, really, pipe by name is not a good name anymore, right? Let's rename it to pipe by name to feature. Okay. points at C directions. Okay, and we're putting in make pipe, which is the type of pipe. I guess that's fine. Okay. So it shouldn't be taking a maybe pipe anymore. It should take a feature and should return a feature. And so we have to call pipe on infer pipe type of C. Yeah, initial grid, I guess. I guess we want to say pipe of P, do that. And if there's anything else, X, surprised by show X. And it shouldn't, no, wait, that's fine. Oh, case look up. Okay, where's this nothing, where's this maybe still coming from? Oh, go. Right, start. So only if we find the start, we say, here's where we are. We're at C, and then we infer what pipe type should be there. And if we get anything else, we just return it, right? And we don't change the origin. We're back to compiling, boys. God, this function's horrible. Okay, let's reload and try prepare again. Hey, it parsed. Obviously, it's a bit of a mouthful. But it ends with coordinate y139, x139, which we like a lot. And it found a 7 there. Oh, you know what would be fun? How far back can I go in this? Not far enough, huh? Okay, but that's fine. I'll just use my programming language instead of my console emulator to tell me what the thing is. 102, 118. Is that what we think it was supposed to be from this? Yeah. I mean, there's 2 off by 1 errors because I'm looking at like no, things are indexed by 1 in Emacs instead of 0, but like, yeah, that's the right place. And it inferred it was supposed to be a 7, right? Which I think is what we believed. Oh, actually, it doesn't say. Okay. But that was what we thought, right? It should go from the left and from below, and that's a 7 shape. So I guess what we could do is say let origin M this to function of origin M lookup origin. What is there at the origin? Couldn't match type feature with IOB. Oh, I guess I really just wanted to fmap this, didn't I? I don't know why I thought I would need to use a bind. Okay, weird. No, wait, stop, come back. Undo that, please. Oh my god. I don't know what I'm doing. Give me this. And just, like, compose that here. Is that? Yeah, there's a 7 there. Great. That's what we thought it should be. So I believe we've parsed the input correctly. Like, go get yourself a celebratory cookie or something. It was certainly a bit of a mouthful. Prepare is just a nightmare. But I think the rest of the code is actually fine. It's a pretty good model of like the whole pipe ecosystem and connectivity within it, and combinators for dealing with pipes in useful ways. Well, not combinators really, but maybe I should move this feature thing a little bit lower though, because I don't know. It's kind of a thing related to features, so maybe it should be up there. I don't know. I don't know how to organize a Haskell file. So let's commit this. I mean, I'm running add-p just to like see if there's anything I hate, but there shouldn't be because there weren't any warnings, and that's all that matters, right? Yeah. Uh-oh, another hunk. Yeah, sure. Day 10. This is like, I mean, parser and infrastructure, kind of. Okay. So, hopefully we can never look at this again. Or hopefully we will never have to look at this again. We will have the option to never look at it. Right? Hopefully we can never do this again could mean two things. It could mean we are forbidden or prevented from doing it again, or it could mean we have the option of never doing it again, which is the one I mean. So part one is basically to shoot two rays counting up the number of ticks until they meet, right? And we could relabel everything with its distance, but we don't know if that's what part two will want of us at all. So I don't think I will. Part one of... origin and grid is... Okay, this is supposed to be an int. Let's just say it's raise 0. Oh, man. I don't want to manage two separate rays. I want to manage a list of rays that happens to be length 2, because that's just going to be simpler. Directions, I guess I'll call these I and J again. Let I and J be endpoints. Let P be... Let pipe P be grid lookup origin. Now, this could fail if there isn't a pipe at the origin, but we know there is, so it's fine. Endpoints of P. I now have a list of the two things. In ray... max distance? I don't know. Max distance 0, I guess, of I and j. Those are the... No. We need to track two things. I origin, j origin, right? Then we need to map a function over this list we have. And then check to see if the two items are the same, basically. Where max distance is a function from list of pair of direction and... Oh, it also takes an int. No, why do I need an int, man? This is so stupid. I should just iterate something, right? Like, really, yeah, don't do this manual recursive tracking of numbers by yourself, you slob. Let's say length of iterate ray traces over this, right? Ray traces is a function. Well, length of iterate is always going to be infinite. So, okay, first of all, I guess I should write map ray trace. So I can just write a function that looks at one thing. And here I can say length of take while not all same. Tail? So the idea is we're going to have this list. We're going to iterate mapping ray trace over it to make each one go one step in its current direction and choose a new direction. Then we're going to drop the first element because that'll just be they're both at the origin. Then we'll say, okay, I'm going to keep going until they're not all the same. Or I'll keep going as long as they're not the same. Then once they are the same, they must have met up, right? And the length of that will be how many steps they had to go before they met each other. I think that makes sense. Not all same. How do you even, like, for a list of n items, which I've generalized to n here for no good reason, but it's just so I don't have to deal with two separate things. Not all same of x's. I know there's a better way to write this. I've seen this before somewhere. Is not all equal x's. Like, and this doesn't mean... I guess we might as well define this, even though it should never come up. Error, no rays or something, right? So ray trace, is its missingness the only thing we're upset about? No. All's apply to too few arguments. Yes, the parentheses should go there. Hello? There we go. Yes, so now the only issue is we haven't written ray trace. But ray trace is pretty simple, right? We've got all the machinery in place. We just have to look at one direction. Hang on. Not all same. We don't care about. They'll never all be the same because they'll have different directions as they pass each other. But if I look at the second element of the tuple, when those are the same, we should stop. Now there. Okay, I guess I'll write ray trace. Ray trace of dir is the direction we're going, and C is where we are. Is case well, okay. This is not quite true. We can immediately say it is our new destination, our new location. Or our direction is what might change. Okay. New direction. And C is... The unit is what I called this? Yeah. Unit C. No, unit... The old direction combined with C. So we're going to walk in the direction we're pointing. And then look at the pipe we've arrived at and change our destination, our direction. This way, they can both start at the origin, walking a different direction, and not get confused. Yeah, I think that makes sense. Where dir prime is... in fact, I need this as well, don't I? C prime. Because C prime is going to tell us what's at our new location, and that's going to affect dir prime. Case grid lookup C prime of, if it is a pipe of P, then we already wrote this function. What's it called? Transit P of dir, right? And if it's anything else, it's just dir, right? If there's a start or a blank here. Couldn't match type. What? Okay. Give me the real type thingy. What's the first error? There are two. Iterate. What's going on? Okay, I don't understand the error messages it's giving me, and so we can often improve the error messages by telling it what type we think things have. Ray trace is a function from direction and coord to another direction and coord. Now I suspect... Oh, they're not called dir. Direction. I expect this won't really help. Yeah, it's the same two errors. Because that one, it's sort of hard to imagine we got that wrong. Now, it seems like it's saying... Look, you told me you would be returning a list of pairs of direction and coordinate. But actually you have a pair of lists? What? Oh, you know what? It's here. Yeah. So, of course, not all same composed with second makes little sense. I'm saying, oh, I'm going to have a tuple. I want to look at the second element of that tuple, which will be a list, and those elements shouldn't be the same. Whereas what I meant to say is I have a list. I want to look at the second element of each of those, the tuples in that list, and check that those aren't the same. So, pattern matches are not exhaustive for feature, huh? Where? Line 64. Yeah, well, that's fine. Let's just stack run, see what happens. It type checks. How could it be wrong? Answer, it's littered with calls to error. That's how. Why is it taking so long to start printing progress messages? I already ran stack build before I started, and like stack GHCI has been running for ages. I don't know why stack run was taking so long to wake from its slumber here. Yeah, there's that one, issue. Did I... Actually... I think I might not be handling empty and start correctly in my ray trace. No, I think I am. 7,004. Is that a plausible number? Probably, right? What's 140 squared? It's about 15 squared times 100, so 22,500? This is about a third to a quarter of the total map. It seems totally plausible. So let's type it in and see what Eric thinks of this. Too low. Well, let's just add one, because I haven't really. I don't think that's actually a good thing to do. But there's definitely some room for off by one errors in here, and if we're too low, maybe adding one would get us the right answer. So we are starting at I origin, J origin. Let's imagine, this is impossible, but let's suppose that I and J were the same. What would happen? We would map ray trace over this. They would both go, let's say, north. We would call ray trace on each of them. North and origin would be dir prime. Whatever. The point is, they would each get a C prime that is north plus where they started. So this iterate map ray trace, I guess I might as well be a little stylistically nicer here, would return a list. The first one being they're both at the origin. The second one being, oh yeah, there's gonna be an off by one in here, I think. The first item will be there at the origin. The second item will be there at the furthest distance. we'll call tail. Now we have a list that's just them both at their furthest distance. Then I'll write this take while they're not all the same. And I'll drop the only item in the list because they're all the same. And I'll end up with a length of 0 where really it should be 1, right? So let's just throw a +1 in there. I believe I can justify that as like, yes, it seems like that was a mistake. I'm not just adding 1 because like I got a too low number and thought there might be some off by 1s. I found the actual off by 1, I think. Let's type in 7005 this time. It's the right answer. Okay. Oh, don't look, don't look. Okay. Git add. So, oh, I typed a semicolon, but it turns out it was okay. So, git commit day 10 part 1. So I think relatively simple. Oh, you know what though? I wanted to. This was only in here for trying to figure out some type error. I don't think it actually belongs in the code. This, I think, definitely does belong. This is... I could use some more function type declarations on this shit. But I won't, because it's added under code, and I'm allowed to be sloppy if I want to. Great. Now it's as if it never happened. So, let's go look at part 2. You quickly reach the farthest point of the loop, but the animal never emerges. Maybe its nest is within the area enclosed by the loop. Ooh, okay. To determine whether it's even worth taking the time to search for such a nest, you should calculate how many tiles are contained within the loop. Yeah, so these 4 tiles are like on the clockwise, or like if you started at S and walked south, these 2 tiles would always be on your left. And nothing else really would be, right? These are always on your right as you go around the loop counterclockwise. Now, I have no fucking idea what algorithm you're supposed to use to understand this, to know what's inside the loop. There doesn't even need to be a full tile path outside for tiles count as outside the loop. Squeezing between pipes is also allowed. Here, I is still within the loop. Okay, what's happening here? I see. Your point is that the loop is not even allowing these O tiles to get in, but they're still like on the right-hand side of the loop as you do this traversal. Any tile that isn't part of the main loop can count as being enclosed by the loop. Sure. How many tiles are enclosed by the loop? So I feel like what you're supposed to do, maybe, is mark those tiles which are part of the loop. Then kind of do a ray trace along the loop in, I mean, can you even, is it clockwork? Does clockwork direction even make sense? Clockwise, I mean? Is that meaningful? Anyway, but like the point is you somehow figure out which side of the loop is the inside and which is the outside from the perspective of the loop. Like one of the two paths around the loop is going to be going clockwise and the other is going to be going counterclockwise, right? And everything on the right of the clockwise path, or if you prefer, the left of the counterclockwise path, is inside the loop. The problem is, how do you know which is which? Okay, even, supposing you could know that, which obviously is possible, but I haven't thought of how. Supposing you could know that, you would want to, whenever you're do a ray trace around the entire loop in, let's say, the clockwise direction, holding out your right hand. Whenever the tile to your right is not itself a part of the loop, you would start a flood fill from that position, marking every non-loop tile reachable without passing through part of the loop from that position as this is enclosed. Then, once you're done with the ray trace, you stop and you go back and you count how many things are marked as reachable, right? So I don't understand, like, how do you know what's clockwise and what's counterclockwise? Can you just, like, if you're at a 7, is it always the case that, like, what's to the southwest of you is within loop, for example? The south or west? Is that true? I guess so, right? Is it, though? I want to look at a simpler pipe. Okay, great. Here's a simpler pipe. So suppose we just, instead of starting at the origin, we started at this 7, because I was just talking about 7s. I claimed that everything to the south or west of a 7 that is on the pipe loop is inside the loop. And yet there's a very clear counterexample here. Here there's a 7, part of the loop, and what's southwest of it is this, and that's outside the loop. So, how is it that, like, I can look at this and say, of course, to the right, as you're walking to the right along this, what's below you, i.e. to the right in your perspective as you walk to the right, is outside the loop. I think it's because I'm looking at these and saying, well, I know those are outside the loop, so the left of this line must be outside the loop, which means the right of this line is inside the loop. Right? So maybe the point is not to do any tracing of the loop at all, but rather to mark down somewhere in a set which tiles are part of the loop and which aren't. And our ground truth, I guess, is that anything along the edge of the map that isn't part of the loop is outside the loop. And then if you cross the loop perpendicular to a section, to a straightaway, basically, you are inverting whether open sections are part of, whether non-loop features are part of the outside or the inside. I think that makes sense, right? Because let's start here. If we say for sure this is outside the loop, and then we look at this and say, oh, this is a vertical pipe section. We're allowed to cross it horizontally, but if we do, we have to flip whether we're claiming the cells are inside or outside the loop. So I get to these two, and I mark them as inside the loop. Then I can either cross this to up here, inverting the meaning again, and I'll get that this is outside the loop, and likewise that this is outside the loop, which is all correct. My problem is, what do I do about corners of the loop as I'm progressing inward? Right? Because if I know this is part of the loop, sorry, not part of the loop, it's outside the loop, then I try walking to one of its neighbors, say here. Where can I walk to next from here that makes any sense? And I guess the answer sort of is only inward diagonally. Like this 7, I can walk. Maybe this is a better example. Let's say I got to here somehow, and I knew this was outside the loop. Then I could walk to here and say, okay, well, everything inwards of this is inside the loop. Then I would say, well, this square is definitely inwards of that, and then I could keep flood filling from here, right? And what if this were another F? I think that would correctly mean that this has to be outside the loop. Obviously, in this drawing, that's not the case. Do we have any examples like that? I don't know. It's kind of hard to understand. But I mean, I guess I could draw it. Oh, this is still the math from the quadratic formula day, huh? Okay, we can get rid of that. I'm imagining a grid like this. Or no, this wouldn't be a 7. It would be a J, I guess. And this is an L, J. Oh, does this need to be even bigger for my example? Well, no. If this were an L as well... Yeah, I guess it does need to be a little bigger. There's no squares left to exist. Like this, right? And now suppose the whole map were surrounded with dots here. And dots... Well, the problem with this is now I could just work my way in this direction and I would know this is outside the loop, right? But I wanted to prove that you can, my idea about how to handle diagonals works. It does, because this loop currently contains nothing. There's nothing within it. If we added another row here, then this is inside, right? But without that, from here to here is just like an empty section of the loop, and this is back outside. But like, then what do you do if... Like, what if the local area looked like this? Obviously, this would be impossible here, but... if you get to this F, and you go southeast, and you get to a line... I guess you can follow the line south and only south? Like, that sort of makes sense. And when you do, you'll mirror the meaning of insideness again. I mean, this seems like an approach that you could make work. It doesn't seem easy. Is there a better way? I'm not so sure. Well, I guess you could try the clockwise counterclockwise thing. I'm not sure it's any better. But the problem I had earlier with the counterclockwise was that, like, looking at a horizontal section, you can't really tell whether above it or below it is inside the loop, right? But you could combine it with this flood fill thing where you say, like, if in the course of your flood fill you encounter the outside of the map, then you must be tracing the outside. But if you don't really know whether you're tracing the inside, do you? Not really. I don't know. Tracing inward from the outside of the map seems to make the most sense to me. And it seems hard. I don't know. I'm like, this is enough for me right now. I might make this a part 1 and a part 2 video, or I might just like never do the part 2. But I've been at this problem for a long enough time that I'm gonna declare an end to this video, and I'll muse some more about the right way to connect this back all up. Anything we should review about? Oh God, don't make me look at prepare again. This stuff is all beautiful-ish. Part 1 is fine. Prepare is just a seething mass of chaos. I mean, it's broken up into these like 4-line functions that are all individually understandable, I think. It's just like you get a certain feeling of your heart seizing up when you see indents go this far to the right for this long, right? An indication that something's wrong. I mean, obviously we could reduce the indentation by using where instead of let here, but that's not like actually an improvement. Yeah, I'm going to leave it at here for tonight. Hope you guys enjoyed. Thanks for watching, and I'll see you next time. Whether that's for part 2 of this or for tomorrow's video, we shall see.